Welcome back, guys. So now let's see the third question in the weekly Leetcode contest 268 range frequency queries. So now first of all, I will explain the question. So what the question is that like we would be given an array, and what we have to find is we have to run some queries on it, and what the queries would contain is left and the right index, and all the elements in between them, and uh, whose value is value as given in the query. Those all elements, the count of all those elements we have to find. Like we have to return the frequency of value in subarray array of left to right. So this is basically the question. Okay, so now let's see the constraints, because in such problems seeing constraints is important. So these are the constraints: that array length is less than equal to 10 to the power 5, array value is less than equal to 10 to the power 4. So the value is less than equal to 10 to the power 4. So here we can do something and we can find. So now let's see the approach. Okay, so what I have done is I have created a frequency array of vectors. Okay, so what I am storing in them is that frequency of array of I dot pushback I, which means that like what I am doing is, let's say a particular value x comes at index 5 of the array. Then what I will do is frequency of x dot pushback 5, because where x came at the fifth index. So what I will do is I will find that index in the frequency array, like frequency array. I will find that index, and that index would be the represent the value of the particular element in the array, that is array of I. And then there I will push back the index at which that particular value came. So x came at fifth index, so I will put frequency of x dot pushback 5. Okay, so this is what I have done, and why I have done so. Now let's see again, because uh, like as you can see, frequency of I now contains at the end, uh, after each iteration of my array, what it contains it is all the indices of the array whose value is I. Frequency of I, what it contains, it contains all the indices of the array whose value is I. Okay, so now we would be given the query and we have to find the number of such occurrences in a particular range of that particular value. So what we will do is we will take the vector of that particular value, and we will try to find the answer from that array. Okay, we will count the all such occurrences such that they are greater than equal to left and less than equal to right. We will find all such occurrences in our frequency of value array, because it only contains all the indices at which the value has occurred in the array. So I will check each and every value, that whether it is whether it is greater than equal to left and less than equal to right or not. If it is, then I will take that into my answer, because this is what I want. This is what I want to return in the query: the number of elements which come between left to right and whose value is the given value. Okay. So this is all what we have to return. So simply I will iterate over this array and I will return my answer. Okay, but the complexity would be greater if I iterate through each and every value of this vector. Then it would be very hectic, and it would be like the time complexity will rise, and it would give us TLE. So in order to overcome that, what we can do is we can use a binary search, or you can directly use the STL functions upper bound and lower bound. So what you can do is you can, like as we know that frequency of value is sorted. Why? Because we iterated in a sorted manner in the array. So that's why it would be sorted only, because each index which is smaller I have inserted in the array before and only. Like you can see that every smaller index I am inserting. Uh, okay, like number wise I am inserting, so it would be sorted. Okay, so now what I will do is I will first like now let me take another page. Like I'm telling that upper what I will do from upper bound and lower bound. So now you agree that this is our frequency of value vector. Okay, now we'll operate on this. Here are something values A, B, C, D. Okay, and these contains indices. In these represent indices in the real array. Okay, so now we have to find all such indices which are greater than equal to left and less than equal to right. So if I iterate over this array and check for each and every, then it would be hectic. But one thing that I know is it is sorted. Okay. So now what I can do is I can apply binary search here, or we can simply say the upper bound lower bound function. So what I will do is I will find an index which is just greater than equal to left. Let's suppose B comes. So I will find that particular index. What that value will give me? 1, because B is just greater than equal to left. So I'm supposing that upper bound that I ran, what would be that? Lower bound. Sorry, you can search on Google like this function. It is in HTL. So what I will find is for left variable, and we are supposing that it comes here, like which means B is greater than equal to left, and B's index is 1. Okay. Similarly for right also I will find upper bound. Here I found lower bound. Here for right I will find upper bound. So let's say D comes. At what index D is? 1, 2, 3. Third index. Third index, which means before this and after this, including this, these all elements are our answer, because these all elements lie between this range. So these all elements are answer. So how we can directly take them as like how we can uh, produce from them our answer? It would be similarly. I will do it for re equal to upper bound. I will use for right, and I will store the indices, like I will store the answer re and le. Okay, so re minus le, like 3 minus 1, which is equal to 2, would be our answer. Hence, as you can see, yeah, it should have been our answer. So we are now pretty much done. That two elements are in the original array which have the value that has been given to us, and they lie between the given range. Yeah, this is what I have done. Now let's see the code. Ignore the map and all such things. Map, you can ignore the map. You can directly see the frequency that I have. You can start from here. Like I have pushed back the index at array of I, as I told, and in query what I did was, like, I found the left index, I found the right index, and then I return re minus le. Okay, so yeah, that's it, guys. Thank you very much.